Hi, my name is Ria, and this is Lab 5 for Physics 2211. So in this lab, I observed how the mental principle applied in real life by modeling the position and velocity of an object in motion. In this case, I chose to model the standing broad jump world record, which is currently held by Byron Jones, who is a cornerback for the Dallas Cowboys. He was actually able to jump a total of 12 feet and 3 inches, which roughly equates to 3.74 meters. I wanted to observe how a computational model and how observational physics can differ in practice. And the main concept I used in the process of this lab was Newton's second law, or the momentum principle, which states that the change in momentum of a system is equal to the net force acting on the system multiplied by the duration, which also means I was able to update the final velocity of Byron Jones in my GlowScript code by using the initial velocity plus the net force divided by the mass multiplied by the change in time. Just to show the video that I used. And that's him jumping a total of 12 feet and 3 inches. So as you can see here, I inputted my data into Tracker to track the distance that was traveled. And as you can see here, you can see there's 3 phases in the graph. The first phase from 0 to 0.3 seconds is when he's slowly gearing up to jump. He sort of swings back before he preps to go forward, as he prepares to go forward. And then you can see the majority of the graph, which is the jump. It's the largest portion of the motion, and it's also the largest portion of time. And then you can see the third part of the graph where he's slowly standing up and straightening out. One assumption I had to make while inputting this data into Tracker was his center of mass. After doing some research, I found that the average male's center of mass is roughly 10 centimeters below their navel or at the top of their hip bones. And that's something I tried to keep in mind while I was inputting this through Tracker. It was a little bit difficult to see as the video is pretty quick, but I tried to do my best to stay around the same region to keep the data consistent. So the prediction of position, there were a couple of things that I had to research before I inputted this into GlowScript. This graph was actually taken from the GlowScript code that I wrote. I had to research his weight, which I found was 198 pounds, which made his mass out to be 44.45 kilograms. I then found his initial velocity, which I found using 2 initial points. So at time t equals 0, his initial position was 6.45 times 10 to the negative 2 meters. And at 1 second into the video, his position was 3 meters, according to the Tracker data. So using that to find my initial velocity, I found that his initial velocity was 2.9355 meters per second. I also noted that the time of the last observation was 1.87 seconds, and assuming constant velocity, I was able to plug this into the GlowScript code to get a predicted position versus time graph. And according to this position versus time graph, at 1.87 seconds, he should have only traveled 5.47 meters. So after plugging this data into a graph to check the difference between the actual and the predicted position, I found that there were some differences. And again, as you can see, there are 3 portions to the actual data, which is highlighted in blue here, and the predicted data is a much more linear graph. After doing some analysis, I came to the conclusion that because we are attempting to model a human, the center of mass could be a little bit more difficult to pinpoint. I know that's something I had a little bit of a hard time while putting the data through Tracker. The model and the experimental data also look pretty different due to friction forces, such as air resistance. The main friction force in this analysis was the friction force. I also noted that the force of the jump was going not only in the x direction, but also in the y direction, which could have led to some differences in the predicted data and the model data. Overall, I think this was a great learning experience and learning to compare actual data versus predicted data. Thank you.